All right, let's tackle quadratic functions. Quadratic functions are characterized by the output term, in this case y, being the square of the input term, in this case x. So we take a number, substitute it in for x, we square it, and that becomes y. So if we take a look at a few points here, I just started to save a little time, I put in some values for x. If we substitute in -3, then we get y equals -3 squared, which is 9, positive 9. Which is the same value we get if we substitute in y as or x as +3, because +3 squared is also 9. So we end up with a 9 down here too. And we can see the same thing will happen when we square -2. We'll get +4, which is the same we get at +2. And -1 squared is 1, and so is 1 squared. At 0, 0 squared is just 0, so that doesn't change the y value either way. So let's put these points on our graph. We'll have 3 and 9, and we'll have -3 and 9, and then we have 2 and 4, and we also have -2 and 4, and then we have -1, 1, and 1, 1, and 0, 0. And if we sort of get a cleaner view of that, that looks a little like this here. So you can see these points are on both sides of the y-axis. They mirror the y-axis. And since we have our origin point down here at the bottom, that means that all the points that we plot are going to be the same distance from that origin point, from that 0 point. That's why we're mirroring the y-axis in this case. If our point of our parabola, that's what this characteristic U shape is called, were somewhere else, then all the points would be mirrored on a line right up through the center of that point, wherever it was. If we connect those lines with a curve, we can see here that that curve should be nice and smooth because it's actually a rounded series of values. If we were to pick, say, 1/2 for x, then y wouldn't be clear over here on 1. 1/2 squared is a quarter. So if we had 1/2 for x, we should have a quarter for y. And that'd be the same thing as if we had -1/2 for x. We'd end up with -1/4 for y. So then we'd end up with a point here and here. I know that's really hard to see, sorry. The important thing is to make sure that as you graph a quadratic function, you picked enough points that you get this characteristic U shape. If we, for instance, had just picked points for x that were negative, then we'd have just this side over here, which would be a curve, but it wouldn't be that U shape. And if we'd picked some that were just something below -2, then we'd end up with just this section up here of our graph, which would be almost a line, and we might think that we were graphing a straight line. But if we have this x term squared, then that's a quadratic function, and it shouldn't be a straight line. So you may have to zoom out and pick some points that are farther apart to make sure you get this whole characteristic U shape, which is very important for graphing parabolas.